Welcome to another video by Adeptis Academy. Have you ever stopped to think about how much data we encounter every day? It's truly mind-boggling when you consider it. From the moment your alarm clock goes off to the last text message you send, we're swimming in a sea of information. Every action we take, every click, every swipe adds to this vast ocean of data. And guess what? Someone or something has to make sense of it all. This is where the magic of data processing comes into play. That's where data processing comes in. Imagine it as taking a messy pile of ingredients and turning them into a delicious cake. It's a meticulous process that requires precision and skill. Data processing is like taking a messy pile of ingredients and turning them into a delicious cake. It's the invisible force that takes raw data, like numbers, letters, or even images, and transforms it into something meaningful and useful. This transformation is crucial for making informed decisions and driving innovation. Think about it. Your phone wouldn't know what to do with a bunch of random taps and swipes without data processing. It's the brain behind the operation, interpreting your actions and responding accordingly. From the apps on your phone to the traffic lights on your way to school, data processing is the unsung hero of the modern world. It ensures everything runs smoothly and efficiently. It's what makes our increasingly digital lives possible. Without it, our world would be chaotic and unmanageable. So buckle up, science fans, as we embark on a journey to demystify data processing. Together, we'll explore how this incredible technology shapes our daily lives and the future. Data processing isn't some magical wizardry. It's actually a systematic process with distinct steps. Each step plays a crucial role in transforming raw data into meaningful information. This process, known as the data processing cycle, ensures that data is handled efficiently and accurately. It involves a series of actions that convert data into a more useful form. The journey begins with input, which is just a fancy way of saying getting data into the system. Input can come from various sources and in different forms. This could be anything from typing on a keyboard to snapping a picture with your phone. It could also include scanning barcodes, recording audio, or even collecting sensor data. Once the data is in, it's time for processing. This is where the real magic happens, as the raw data is transformed into something more meaningful. During processing, the data is manipulated and transformed. This step can involve a variety of operations, depending on the nature of the data and the desired outcome. This could involve performing calculations, sorting information, or even converting it into different formats. For example, numerical data might be summed up, text data might be sorted alphabetically, or data might be converted from one file type to another. Think of it like following a recipe. You're taking the raw ingredients and mixing, baking, and frosting them into a finished product. Finally, we have output. This is where the processed data is presented in a usable form. The output can take many shapes and forms, depending on the needs of the user. It could be a report on your computer screen, a notification on your phone, or even just the movement of a robot arm. The key is that the data is now in a form that can be easily understood and utilized. Of course, we can't forget about storage. This is a critical step to ensure that the processed data is not lost and can be accessed later. This step ensures that the processed data is saved for later use, like a digital filing cabinet. Whether it's stored on a local server or in the cloud, proper storage is essential for data management and retrieval. Just like our brains control our bodies, computers rely on powerful components to handle data processing. At the heart of it all is the Central Processing Unit, or CPU. Think of it as the brain of your computer. The CPU is responsible for executing instructions and performing the calculations necessary for data processing. It's a tiny chip packed with billions of transistors that act like tiny switches, turning on and off to process information with incredible speed. CPUs come in different speeds and configurations, but they all share the same goal: to process data as quickly and efficiently as possible. The faster the CPU, the more instructions it can execute per second, leading to a smoother and snappier computing experience. Imagine trying to bake a cake without any counter space to work on. That's what it would be like for a computer to process data without memory. Memory is essential for storing data temporarily while the CPU works its magic. There are two main types of memory: RAM and storage. RAM, or random access memory, is like the computer's short-term memory. It's super fast and allows the CPU to access data quickly, but it's also volatile, meaning that its contents disappear when the computer is powered off. Storage, on the other hand, is like the computer's long-term memory. This is where data is stored permanently, even when the computer is turned off. Hard drives and solid-state drives, SSDs, are common examples of storage devices. Now that we know how data is processed, let's talk about how we get it in and out of the computer. This is a crucial aspect of how we interact with technology daily. That's where input and output devices come in. These devices serve as the bridge between us and the digital world. Input devices allow us to send data to the computer, while output devices allow the computer to send data back to us. This two-way communication is fundamental to computing. Think of it like a conversation. Just as we speak and listen in a dialogue, input and output devices facilitate a similar exchange with computers. When you type on a keyboard or click a mouse, you're sending input to the computer. These actions are translated into data that the computer can understand and process. The computer then processes that input and sends output back to you through the monitor or speakers. This output can be in the form of text, images, sounds, or even complex animations. There are countless examples of input and output devices, each designed for specific purposes. They range from simple to highly specialized tools. Scanners, microphones, and even gaming controllers are all examples of input devices. These tools help us feed various types of data into the computer. Meanwhile, printers, projectors, and headphones fall under the category of output devices. They help us receive and interpret the data processed by the computer, making the digital experience tangible and interactive. Data isn't always neatly packaged in ones and zeros. Sometimes it comes in the form of continuous signals like sound waves or radio frequencies. To process these signals, we need a special kind of data processing called signal processing. Signal processing is like taking a messy ball of yarn and carefully untangling it to reveal a beautiful tapestry. It involves manipulating signals to extract useful information, reduce noise, or even enhance certain characteristics. Think about listening to music on your phone. Signal processing is what allows your phone to convert the digital music file into audible sound waves that you can enjoy. It's also used in medical imaging, telecommunications, and even earthquake detection. From the mundane to the extraordinary, it plays a vital role in countless aspects of our lives. Let's take a look at some real-world examples of data processing in action. Think about your smartphone. It's a data processing powerhouse. Every time you take a picture, send a text, or even just unlock your phone, data processing is happening behind the scenes. Social media platforms rely heavily on data processing to personalize your newsfeed and connect you with friends. In the medical field, data processing is used to analyze medical images, monitor patient vitals, and even assist in complex surgeries. Self-driving cars rely on a sophisticated network of sensors and data processing algorithms to navigate their surroundings safely. As technology continues to advance at an unprecedented rate, the field of data processing is constantly evolving. New trends and innovations are emerging, promising to revolutionize the way we live, work, and interact with the world around us. One such trend is the rise of artificial intelligence, or AI. AI algorithms are becoming increasingly sophisticated, enabling computers to learn from data and make decisions without human intervention. This has profound implications for fields like healthcare, finance, and transportation. Another exciting development is the Internet of Things, or IoT, where everyday objects are connected to the internet, generating massive amounts of data. Data processing is essential for making sense of this data and unlocking its potential to improve our lives. Data processing is the invisible force that powers our digital lives. From the smartphones in our pockets to the self-driving cars of the future, it plays a vital role in countless aspects of our world. As technology continues to advance, data processing will only become more ubiquitous and essential. Understanding the basics of data processing is crucial for navigating our increasingly data-driven world. By demystifying this complex field, we can appreciate the ingenuity behind the technology we rely on every day and prepare ourselves for the exciting possibilities that lie ahead. So, the next time you snap a selfie, stream a video, or even just check the weather forecast, remember the amazing world of data processing that makes it all possible.